Hi, my name is Imran Aslam. Today you are watching the program to calculate the K factors for the fittings and the valves. Here from the menu at the top, you can select the K factor calculations for the fittings and the valves. But for this program, I will only demonstrate the K factor calculations for the fittings, and some other time I will demonstrate the K factor calculations for the valves. Here in this page you can see several pictures are shown, which are basically the most widely used fittings in the piping system. Now let's start with the first type of fitting, which is sudden and gradual contractions. Here in this picture you can see there is a smaller diameter pipe and the larger diameter pipe are connected together with some angle of deflection over here. In this calculation, D1 is my smaller inside diameter of the smaller pipe and D2 is the inside diameter of the larger pipe. Here in this field over here, D1, for example, I will select 3 inches as the inside diameter of the smaller pipe and 4 inches is the inside diameter of the larger pipe, and theta is the angle of contraction, which is, let's say, 30 degree. Now N is the total number of contractions in the entire piping system, which is, let's say, are 10. Now if I press the calculate button here, the K value for the 10 contractions in the entire piping system is calculated and shown in the field over here, and the message box and the message bar below turns green with the remarks OK on it. Now let's move to the other type of fittings, which is sudden and gradual expansions. Here again, D1 is the smaller diameter of the pipe and D2 is the inside diameter of the larger pipe, and theta is the angle of expansion. And now for this calculation, I will say, let's say D1 is 3 inches and D2 is 4 inches and theta angle of expansion is 15 degree, and N is the total number of expanders in the piping system, which is, let's say, 30. Now if I press calculate button, the K value for the total expanders in the entire piping system is calculated and shown in the field here, and the message box turns green with the remarks OK on it, which means the calculations are completely done. Now let's move to the other type of fitting, which is a standard T. Now again, D is the diameter of the T, which is, let's say, 6 inches, and while I type 6 inches, you can say the message bar turns red with the remarks error on it, which means that something is wrong with the calculation. But actually there is nothing wrong with the calculation. If I type total number of T in the piping system, which is, let's say, 10, the K value is automatically calculated and the message bar turns green with the remarks OK on it, which means the calculations are completely done. Here you can see there is no calculate button. Calculations are done while I type inside the field over here. As I type here, you can see the calculations are done at the same time. Okay, now if I move to the next type of fitting, which is again a T, which is a standard T flow through branch type. Again, D is the diameter of the T, which is, let's say, 3 inches. N is the total number of T in the piping system, which is, let's say, 5, and the calculation for the K will be automatically done and shown in the field here, and the message bar turns green with the remarks OK on it. Okay, now let's move to the other type of fitting, which is standard 90 degree elbow. Again, D is the inside diameter of the T, which is, let's say, 6 inches, and N is the total number of 90 degree elbows in the entire piping system, which is, let's say, 10, and K value is calculated automatically while I give the inputs in the two fields over here, and the message bar turns green with the remarks OK on it. Now move to the next one, which is standard 45 degree elbow. Again, D is the inside diameter, which is, let's say, 8 inches, N is the total number of 45 degree elbows in the piping system, which is, let's say, 5, and the K value is calculated automatically and message bar turns green. Now move to the next one, which is meter bends. Again, D here is not the inside diameter. D is basically the linear length from the center of the meter band to the edge of the meter band, and in this case I will select D, for example, is 4 inches. N is the total number of meter bands in the piping system, which is, let's say, 10, and here alpha is the angle of deflection in the meter bands, which can be selected from this drop down list, and for this example I will select 15 degree, and the calculation is done at the same time automatically, and the message bar turns green with the remarks OK on it. Now move to the next one, which is meter bands. Again, D here is the inside diameter of the meter band, which you can see from the picture over here. Let's say D is 2 inches. N is the total number of meter bands in the piping system, which is, let's say, 5, and here R by D, which is the radius to diameter ratio, which can be selected from this drop down list. Here for this example I will select 3 as a ratio, and the K value is calculated automatically at the same time while I give all these 3 inputs, and the message bar turns green with the remarks OK on it. The next one is closed return bands. Again, D is the diameter of the closed return band, for example, which is 4 inches. N is the total number of return bands, which is, let's say, 8, and the K is calculated for all the 8 closed return bands in the piping system, and the message bar turns green with the remarks OK on it. The next one is the pipe entrance. Again, there is no diameter input is required for the calculation of K factor for pipe entrance. Only the total number of pipe entrances are required. Let's say it is 1, and here R by D is the ratio of radius to diameter, which can be selected from this drop down list, and for this example I will select 0.04, and the calculation for the K factor for this pipe entrance fitting is calculated automatically, and the message bar turns green with the remarks OK on it. Thanks for watching this video. Again, for any comments and questions, or to buy this video for your computers, please contact Imran Aslam on this email address. Thanks. Bye.